Hello and welcome to session 278 in the AISafety.com reading group. Tonight we will be discussing the article Against Almost Every Theory of Impact of Interpretability by Raphael Segeri. Raphael Segeri is the co-head of the AI unit at Efficience, the student collective at the École Nationale Supérieure in France. This is a less long post, not an article as I said before, roughly a month old. And this is, as you may notice, the first foray this reading group has done into interpretability work. And of course that's very interesting to it's a big field that I feel bad for not treating more here. In this article, Raphael suggests that we focus on a specific subset of his work, and we'll try to do that. But let me just see if I can get this away. Hold on. There. And then there was some part that I thought was important that I also added. So first, on a meta level. This is a critique of the field that Raphael is working within, and I think you get substantially more credibility for going for criticizing your own field compared to someone from the outside that doesn't work with interpretability. Also because like you have incentives, you earn possibly a paycheck in doing interpretability work. So I appreciate that. He is making claims that are he describes them as on the strong side, and this is something that my personality objects somewhat towards. I don't like to do that, but I do in fact endorse that you should try to do that. For instance, if someone thinks that I am having a negative impact with the work I'm doing, then I want people to have a really low barrier to telling me this. And make a strong statement rather than being forced to really educate their statements. He's also an advocate of using memes for communication. I think that's important, and I think he should have used more. Like, that's of course easy for me to say that you should use more than two memes, because humor is just really hard. And one of the memes are references a song called "Hook Me Up, Baby." Like I was trying to figure out what that was, and it seems this is memes at such a level where even ChatGPT has no recollection of this song in particular. So I think there is probably some deeper point here that we are getting something that ChatGPT in fact does not understand. So the first part, which is actually the last part of Raphael's article, is that there are technical agendas that have a better theory of impact than interpretability work. I believe this is very true. I believe, for instance, I want to plug my own favorite, which is that we should try to have a gears level understanding of anapatistic reasoning. The three that Raphael points out
what
are...
is
Anapatistic reasoning.
What is
Anapatistic reasoning is reasoning where you understand that your own reasoning is flawed. In poetic statements, we want the AI to see itself on the inside, have the same inside view of its own mental capabilities as we have on the outside. So the three that Raphael suggests are technical works used for AI governance, figuring out what are the technical difficulties of alignment, and technical outreach. These are three things that I agree have a much better, at least a good theory of impact. But Raphael claims that this is the part he's most confident in and doesn't really give any arguments. And I think like that makes it hard to like evaluate. But in general, it seems like his overall view of the strategic landscape, that we should slow capabilities through a safety culture, is something that resonates very much with me. So the first part of what we want to do with interpretability interp is to audit for deception. This is, according to Raphael Chabal-Raphael, the main motivation for doing interpretability work. Neil Nanda is one of the key figures within interpretability research, and he makes the claim that plausibly we could audit for deception just with a very limited ability to do interpretability work, namely the ability to take some bit of a model and figure out what does that part actually do. I think that is unlikely. I think that seems obviously insufficient to the point where I notice that I'm confused. Like, imagine that you have a GPT-4 and you want to figure out, is this deceptive, and then you have the ability to take a small subset of neurons and determine that this neuron encodes knowledge about whether dogs eat potatoes or something like that. That doesn't help you at all, right? You need something far, far stronger, as far as I can tell. Ivan Hubinger has a more refined model of what kind of interpretability would work towards deception. He frames this as a tech tree, where at the highest level of the tech tree you have best case inspection transparency. Like, is there just about any place in the neural network where we can say, okay, this does in fact encode whatever it is that the machine learning model has encoded in a set of neurons. Based on that, the lowest level we can reach level 2, which is figuring out how the training process works, and see that, okay, between these two iterations it's learning more about potatoes or something like that. Building up to something that is robust to training, meaning that if we start to train it towards potatoes or something, whatever we want, then it shouldn't go off the rails, which is something that such a training process can easily do if we try to optimize for something like for anything, basically. The fourth level is to have worst case inspection transparency. Meaning that this is not just that there exists an existence quantifier, there exists a part of the model we can understand, but for every part of the model we can in fact understand this. Building these two on top should perhaps give us worst case training process transparency, which will then give us worst case robust to training transparency, and this will finally allow us to do this for deceptive models, and for hopefully even worst case robust to training transparency for deceptive model, which are the kind of things that we are actually going to need if we are going to use interpretability tools to avoid deception. Chabal-Raphael believes, this was his conclusion, not mine, that this is what is required, and states that we are mostly at level 2 currently in this tech tree. We've tried to dig deeper into the tech tree, and level 4 seems really hard. So it seems like we may not be able to actually accomplish this goal. Ivan Hubinger states that robustness to deception is extremely difficult, and that surprised me, because my understanding was that Ivan Hubinger is one of the, he's really bullish on interpretability, and I think it's more likely that the reason he thinks this is extremely difficult, but all other things are even more difficult, which is somewhat more of a consistent with my understanding. Another issue is passive deception, because in order the classic model of this deception is that the model thinks, okay, I should not reveal my capabilities, and have this kind of explicit explicit thoughts about how it will deceive someone. But that doesn't actually have to be. Like, you could imagine that a model is trained without ever seeing a situation where any kind of takeover is possible, and for this reason, because it's not possible, it will never actually think deceitful thoughts. I agree this is possible. I think it may be possible to fake situations where the AI erroneously believe that it is capable of doing a takeover, and in that case, when presented with such a situation, interpretability work would be possible. I caution against this method because I believe it's way, way, way harder than people naively think. But I think it is something that could, in theory, be done. Another reason why we would expect passive deception is because in general the AI may not be interested in taking over at any point, but just gaining power is really instrumentally useful in many different scenarios. And if there is a clearly defined overseer, then obeying this overseer is something that leads to having more power. Again, I believe that if there is a way to, with interpretability, identify some goal, then it may be possible to say, like, set up situations where obeying is at odds with the objective and see what the model actually thinks about that. Yeah, explicit plans for later deception are not required as stated, and I think this is a very interesting point. And my model of deception is that deception is an extremely natural concept. Like, obviously, once you've thought this through a couple of times and have been pointed out the concepts, then of course deception makes sense. Of course that's the thing it will do, and that means that in every forward pass the model will just reinvent the concept even if it's been erased. And like there is we won't necessarily see the model like using it, thinking about deception in like visible thought projects and things like that. There is also some more general points about interpretability, more conceptual points. I'm confused here why this is in the section of deception, because as far as I can tell, this doesn't really relate directly to deception. But Eliasirkowski in his list of lethalities have given like 3 reasons why we would not expect interpretability to be useful. Optimizing against interpreted thought optimizes against interpretability, and 2 other reasons. And I think both of these are like interesting and true arguments, but they're not really related to deception, at least not directly. Chabal-Raphael also adds a couple of other conceptual points here against interpretability. It's too risky, prevention is better than the cure. He deals more with these arguments in other places, and it doesn't really have much to do with deception, that Morlock may still kill us and we won't be competent enough to fix our mistakes and things like that. I think that there is a strong negative conceptual point against interpretability that isn't really described in this place, and that is that we are potentially in an adversarial regime where the AI knows that we have these interpretability capabilities, and that means it will be able to design a strategy that goes around this, or if it's not able to work around our capabilities, then it won't be deceitful. There are in fact better ways to study deception. Chabal-Raphael has a nice list of different things that have been tried. I really like this list. It's nice to see this formulated in a more prosaic way than most other studies on deception. In particular, he's fond of preventative measures and believes that conceptual advances are more urgent, and conceptual advances in general don't really depend on interpretability in any meaningful sense, and also very positive on simulator theory. That was all about deception. Now we come to a potential way that interpretability could be used for AI safety, and that is enumerative safety. Neil Nanda claims that we may be able to enumerate all features in a model, and then once we do that, then we can just look at the ones that are related to dangerous capabilities, and then check those manually, or more or less manually. I am confused here, because all features of GPT-4, like that's like all subsets of neurons in GPT-4. That's like a lot, right? And that seems totally impossible to enumerate. And Like if you need to do anything for each subset of like 4 billion neurons, that seems totally infeasible. This isn't really Chabal Raphael's objection. His objection is more like, how do you if you have some kind of feature, how do you tell whether it's dangerous? Because one of the things we really want large language models to do is to know what things are dangerous. Like a gun, for instance. It's possible to be very well aligned and safe and still know what a gun is. Like both good and evil models will know what a gun is. And like, how do you look at some kind of feature, like a concept like a takeover? That sounds kind of dangerous, but like power seeking, money, all these kind of things seem really hard to specify precisely if they are dangerous. I think, in fact, that once you get to a super intelligent level, there are so many things you can be killed. I think you can be killed in 39 ways with a wet paper bag. So, like, how would you tell which things are potentially dangerous? And I think more crucially, if we want to build an AI that is capable of doing some sort of pivotal act, then that seems like a thing you totally cannot do without giving it dangerous capabilities. Another issue is the concept of features. This is a place where I actually don't really know anything, so I'm happy for Chabal Raphael to state to what extent this has been formalized, and he says it has been formalized. We've tried to, there's the natural abstraction hypothesis, which may be true. Like we found some counterexamples. One of the ones he mentioned is like addition turned out to be very different in the implementation compared to like how humans do that, and he believes that this is not going to work out. Also, a problem is that when we're talking about dangerous capabilities, we aren't really talking about low-level capabilities. Like something like recognizing a gun isn't really a dangerous capability. A dangerous capability are things like the ability to code, and something like the ability to code is something that is really hard to specify, and we're talking about this situational awareness and things like that, which are very hard to work with on a conceptual level compared to like the color red or something like that. Another problem is that these dangerous capabilities are really, really valuable, because yes, it's dangerous that the AI is capable of writing computer code, but it is also really something that we want the AI to be able to do. So the idea that like once we try to restrict a model from having dangerous capabilities, we very quickly end up with something that has dramatically inferior value. And yet another problem with enumerative safety is that in theory it's quite possible for a system to be deceptive, even if this system is made up by several parts, and then in how they collaborate and how they work together with the environment, that ends up with a deceptive system. The conclusion, again, this is the kind of thing I can't evaluate, but it is stated that these kind of things have been tried and have mostly failed. Finally, this isn't one of the things that Chabal Raphael highlights as the most important, but one of the things that he writes that I think is really important is the fact that even if we get interpretability perfect, then we are still very much in danger. So when I try to formalize this, I imagine several different possibilities. One thing is that like Omega, a super intelligence from a different universe, just hands us a textbook with interpretability work that dramatically improves our interpretability work. Does that put us in a substantially better position? My strong intuition at this point would be no. It doesn't really change much. Even much better interpretability tools would still fail to solve the hardest part of the problem. I think if this textbook like doesn't just solve a lot of the problem, but really truly solves it in the sense that we get provable interpretability, where we can like prove whether a model is deceitful, then I think that does in fact improve things, and does improve things very much. Another thing that improves our strategic situation is that if this interpretability research doesn't come about with like a deus ex machina, but some kind of societal change where people realize this is a real problem, so they start to work more on that. That's also the kind of thing that would reduce my probability of doom. Okay, but that was mine. Chabel Raphael claims that no one has ever claimed that solving interpretability would mean that we are no longer in danger. I think I would roll to disbelieve. I'm sure like there's a lot of people who believe that right now there is very little danger, and of course with completely solved interpretability, a lot of people I think would claim that the danger has passed. There are many potential scenarios people have dreamed up where we end up in a very bad place, even without deceptive AIs doing anything. He also states that total explainability of complex systems with great power is not sufficient to eliminate risks. And I think that's true, but I think a more powerful argument could be made with the opposite framing. And that is that the system is very different from the AI, in the sense that the AI is embedded in some system together with other AIs, together with whatever manipulations it have with incentive structures and with humans and all these kind of things. And the fact that we're doing interpretability on an AI but not on the system itself means that it is quite possible that we will end up in a situation where the system behaves very different from the AI. The obvious example would be a human and an AI collaborating, with the human telling the AI to help the human take over the world, and that could potentially be really bad. And interpretability will not help eliminate this risk. He scares me a bit by saying interpretability implicitly assumes that the AI model does not optimize in a way that is adversarial to the user. I was surprised to hear that this is an implicit assumption, because to me this is really a core assumption or an objection to using interpretability, that we are like trying to uncover something that a potential superintelligence is trying to hide from us, and this is like this adversariality is something that I believe is something that really dramatically influences the strategic landscape. And finally, he asks the rhetorical question: would you feel safe if you could read Voldemort's mind? Voldemort being the villain of the Harry Potter series. I haven't seen or read the Harry Potter books, but I have in fact read Harry Potter and the Methods of Rationality, which also features Voldemort prominently. And I think people who have seen, like I don't, so please take this with a grain of salt, but I think people who engage with normal Hollywood victims would say that, yeah, in fact, being able to read Voldemort's mind does in fact make them somewhat safer, maybe a little, maybe substantially. I think that's what most people would read. And I think people who have read Harry Potter and the Methods of Rationality would be able to recognize that being able to read Voldemort's mind is in fact something that Voldemort can use against them very easily, and the only safe thing to do is to immediately stop reading his mind, and like the only actually safe option would be to not build Voldemort. And I think that is what people should do, and I think Chabel Raphael would agree. That is all for today. Thank you and see you next time.